So for this question, it's an expansion, a binomial expansion to the power of a half. So we're going to be using our bracket to be 1 plus something. So we need to make sure that it starts as 1 plus. So we're going to need to take 4 out of the bracket. So to do that, it's 4 to the power of a half out of the bracket, which would leave us with the 1 here. So we've taken out that whole 4 to the power of a half out, which means we've got 5 over 4x here. And that's to the power of a half. Now dealing with the 4 to the half, that's just root of 4, so that's 2. And then what happens is we're going to be expanding using our binomial expansion formula. We're going to expand 1 plus 5 over 4x to the power of half. So for that to happen, we have 2 brackets, the whole of the expansion. It starts with just 1, and then what happens is we do a half times 5 over 4x all over 1 factorial, which is just this. Plus then it's a half times 1, a half minus 1, which is minus a half, times 5 over 4x and then squared, so we're going up in the powers. Make sure it's all over, all to the power of 2, and that's over 2 factorial, and that's as far as we need because it does say up to and including x squared. So now if I simplify this, I get 1 plus 5 over 8x. If I simplify the next one, what I get is a half times minus a half, which is minus a quarter over 2 factorial, which is minus an eighth. And then we've got 5 over 4 all x squared, so that's 25 over 16x squared. Again, simplifying even further, we've got 2 brackets, 1 plus 5, 8x. And then I have, so that's minus 25 over 128 x squared. And finally, if I just expand the brackets, I get 2 plus 10/8 x minus 50 over 128 x squared, which I can simplify to 2 plus 5 over 4x minus 25 over 64 x squared. So that is our expansion up to x squared. In other words, we're saying that k is therefore minus 25 over 64, which is what it was asking for. So if we have a look at that question there. Part B, we're looking at using x equals a tenth to find approximate value of root 2. So in other words, let's put a tenth in to what we were doing. So that's this. Sorry, that's a half. What we end up with there is 4 plus a half to the power of a half, which in other words gives us 9 over 2, and that's rooted. And finally, we can say that that is actually going to be 3 over root 2. So that means we've got an approximation. If we put a tenth into our expansion over here, we'd get an approximation for 3 over root 2, but we actually want an approximation for root 2. So we can say that if we're putting x as a tenth, what we need is we need that expansion, but we're going to need to multiply it by 2/3, because 2/3 times 3 over root 2 would give us 2 over root 2, which we know to be, if we multiply both those by root 2, we end up with 2 root 2 over 2, which is root 2. So in other words, we're saying that if we multiply it by 2/3, we end up with an approximation of root 2. So what we do is we put 2 plus 5 over 4 a tenth minus 25 over 64 a tenth squared. And then what we're going to do is multiply that whole thing by our 2/3 to actually get our approximation that we're looking for. So if we simplify this, we get 2/3 bracket 2 plus an eighth, if we do 5/4 times a tenth, and then we've got minus 25 over 64 times by 1 over 100, which would leave me with minus 1 over 256. Again, simplifying further, which leaves us with 181 over 128 as our final answer. So that is the approximation of root 2. Okay, you can check that because we can say that 181 over 128 equals 1.41406, blah, blah, blah. And if you type root 2 into your calculator, you also get 1.4142, blah, blah, blah. So it is a good approximation, so that seems like a legit answer. Finally, part II says, explain why substituting x is a tenth into the expansion leads to a valid approximation. So this is why it's important that we've used a tenth, rather than just like in year 1, we would have just equated 4 plus 5x to 2, and then we could have used that value of x. The reason we can't do that is because it only works for certain values. So we know that this bit here has got to be between -1 and 1. In other words, we're saying 5 over 4x, and the modulus of that's got to be less than 1. Therefore, the modulus of x has got to be less than 4/5. So we know that it's valid because x is a tenth, which is indeed less than 4/5. Therefore, it is a valid substitution.